Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Wan Ahmad Ikmal bin Asfarizal and my ID number is MA18142. Today I will present a little bit about abstract for this experiment. So the purpose of the lab is to design experiment using our own parameters, operation guideline and variable which is heat convection. So in this experiment, it includes free and forced convection. Air movement will be introduced in the forced convection, whereas free convection will not need any air movement. In the Z lab are needed to be set up to collect data from the instrument. Aluminium rod and finite plate is used in our experiment. So next, the introduction for the experiment is heat convection is the process of energy transfer between a solid surface and the moving adjacent liquid or gas, and it includes the combined conduction and fluid movement effect. The heat convection above the hot surface occurs because the hot air expand, become less dense and rise. Similarly, warm water is less dense than cold water and rise, creating energy carrying convection currents. The tip convection may also apply to heat transfer for any movement of fluid, but because of bulk fluid flow only, advection is the more appropriate term for transfer, and the heat transfer process from a solid to a fluid or vice versa involve not only the transfer of heat through the fluid bulk motion but also diffusion and conduction of heat through the continuous boundary layer convection, and a process generally referred to as convection. And what we need to know is there are two types of heat convection, which is forced convection and free convection. So I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Al-Mashaki and I will proceed with the objective and the literature review or the related formula used in this experiment. So the objective, the first one is to investigate the transfer of heat by convection both naturally and by force. The second one is to determine effect of fin addition on the heat transfer characteristics. So for the literature review, the rate of heat transfer from a surface to a fluid by convection given by Newton's law of cooling, which is Q equal to A hash times with T. A is the cross-section area, H is the heat transfer coefficient, and T is the mean temperature, Tm. So the basic or the common equation used for convection is Q is equal to H average times with the surface area S times with surface uniform temperature minus with reference temperature. And then the Nusselt number, which is Nu, HD divided with K. H is the convection heat transfer coefficient, K is the thermal coefficient, and D is the surface contact diameter. This parameter is equal to the dimensionless temperature gradient at the surface, and it provides a measure of convection heat transfer occurring at the surface. Prandtl number, PR is equal to mu times with Cp minus with K. So Cp is specific heat and mu is viscosity. Prandtl number is the ratio of the momentum and thermal diffusivities. It is dimensionless and is actually the reciprocal of Reynolds number. So this is the common equation for this is the equation used for free convection equation. Ruffles number Ra equal to the gravity acceleration G times with beta, the thermal expansion coefficient, times with the surface temperature minus with the reference temperature, times with the length of the geometry, minus with the kinetic viscosity and thermal diffusivity, which is alpha. Rayleigh number is based on the characteristic length L of the geometry. Note that all properties are evaluated at the film temperature. Also, the Nusselt number will times with L, the length of the geometry. So H is the convection heat transfer coefficient and K is the thermal coefficient. C is a constant and N equal to 1 over 4 for laminar flow and N equal to 1 over 3 for turbulent flow. For force convection equation, the Reynolds number Re equal to rho Vd minus with mu. Reynolds number as shown is used for the following geometries to determine the fluid flow condition. So this is all for me. Thank you.
Assalamualaikum. My name is Muhammad Nur Sufyan bin Sudin, PID MA18263. So I will continue presenting for the next data, which is the apparatus and experiment procedure. So as we can see, this is the schematic diagram for the experiment of the free and forced convection that consists of fan, air duct, fin, arm fin and cylindrical fin plate, heater, power regulator, digital power meter, anemometer, plate heater placement, fan speed regulator, temperature sensor and data logger. So this is the LS17004 FFC free and forced convection apparatus. Apparatus and software setup. Ni that software is open and startup to synchronize sensor. Second, the Z-LED software is then open, then the Z-LED is synchronized in order to get the reading from the NIDAT. The suitable module is selected for the Z-LED setup to record of the result for temperature from the heat transfer by convection. Third, the apparatus setup according to the right configuration. So, for the free convection procedure, first, the LS1704 FFC free and forced convection apparatus is placed on the level table. Second, the power supply unit in front of the control panel is switched on. The desired test specimen selected and attach the plate heater to the air duct. Then the plate heater is connected to the power socket located at the back of the control panel. The initial temperature in the air duct is measured by using the digital handle temperature probes and meter into the temperature at level E at this point. Next, the temperature probe is placed to the point level D at this level D. 5. You regulate the power supply to 25 watt by turning the power regulator. 6. The temperature at point level D is measured and recorded into a table for every 5 minutes. 7. The experiment is continued until steady state is achieved where the temperature reading at the point level D became constant. 8. Step 1 until step 6 is repeat with other type of specimen. And lastly, step 1 to step 7 repeated with power supply of 50 watt, 75 watt and 100 watt. For the forced convection, step 1 until step 3 is same as the free forced convection. For the fourth step, the initial temperature in the air duct is measured by putting the digital handle temperature probe into the temperature point level E at this point. Then switch on the fan and the anemometer placed to the point at level E. 6. The fan speed is set to the 0.2 meter per second. 7. The power supply is regulated to 100 watt by turning the power regulator. The temperature at point label D is measured and recorded it into every 30 minutes. Night. The experiment is continued until steady state achieved, where the temperature reading became constant. So the step 1 until step 9 is repeated with different fan speed, with 0.6 meter per second, 0.9 meter per second, and 1.1 meter per second. And step 1 until step 9 is repeated by other type of the specimen. So I think that's all from me.
Thank you, Muhammad Sofyan. Now I will continue to present about result and discussion. For results, first question, for the plot graph of temperature against time for free convection. As you can see, this is the result for the free convection for the cylindrical. This is the time versus temperature. We have result for power 25 watt, 50 watt, 75 watt and 100 watt. This is the plot graph for the free convection. As you can see, the increase of the time, the temperature will also increase. Okay, next for the second question is the plot graph of temperature against time for forced convection in cylindrical plate for power 100 watt. As you can see, this is the time versus temperature result, and this result is for air velocity 0.2 millisecond, 0.6 meter per second, air velocity 0.9 meter per second, and lastly for result 1.1 meter per second. Next, for the graph for the forced convection, as you can see, this is the graph for the forced convection. For the third question, calculate the mass flow rate of the air and the heat transfer rate. Okay, for the mass flow rate, we use formula m dot equal to rho av. For the free convection parameter, we use v equal to 0.2 meter per second, and the area we use 0.07905 meter cube. We use sample example for power 2.25 watt. The rho we use is 1.1161 kilogram per meter cube, and we got the mass flow rate 0.01765 kilogram per second. For the example for the forced convection, we use rho 1.225 kilogram per meter cube, and the area we use same 0.07905 meter cube. And for the V we use 0.2 millimeter per second, and then we get the mass flow rate 0.051595 kilogram per second. And the heat transfer rate as Q dot equal to HA TS minus T infinity to and multiply by watt. And the answer we got the and for the free convection, we got the heat transfer rate, we got 11.8501 watt. And for example for forced convection, we use velocity 0.2, and then use the same formula, we got the 70.11796 watt. After that, for the last result for the fourth question, the plot of the heat transfer coefficient versus velocity for forced convection. As you can see, this is the plot graph. As you can see, the increase the velocity, the heat transfer coefficient will also increase. And for the discussion, based on the result that have been given in this experiment from the above graph, for the free convection, the higher the time, the temperature will be higher. But for the power of 25 watt, after 85 minutes and above, the temperature will remain constant at 50 degrees Celsius. For the forced convection,
The faster the air velocity, the lower the temperature reading. The larger the surface area, the higher the rate of heat convection that occurs. And this results in a higher convection rate, which is produced by rod. The heat transfer of the convection depends on the movement of the fluid. So the air speed is the same. However, because it is a larger superficial area, the heat transfer for the fin plate is always smaller. And of course, from it we can know for the highest heat transfer coefficient is in turbulent flow, because a larger pump is required to overcome the high friction at the maximum heat transfer rate. That's all from me. Thank you.
In conclusion, the purpose of this experiment is to analyze heat transfer of both natural and forced convection. Besides that, the impact of heat transfer attributes between fin and rod is compared. The data from the experiment conclude that the rod has the ability to transfer more heat than fin plate, which is due to the larger surface area that is possessed. In free convection of fin plate, the convection heat transfer is lower compared to rod. In contrast, the heat convection in the rod is efficient due to the presence of air velocity. This situation occurs due to the fact that the surface area is smaller in fin plate. The larger surface area of the rod results in the rod to be more efficient in forced convection. The effectiveness of forced convection has the ability to be higher if the fan force a more rapid fluid velocity than the movement velocity of the air that is fulfilled by the free convection, which is due to the fact that the rise of fluid velocity has the ability to accelerate the convection heat transfer coefficient substantially.